Check one, check one, check one. Right. Hello, everybody. This is our Chem backup. Chem backup කියන්නේ chemistry. Some important sections in your grade 10 chemistry are going to be revised today, right? You already have finished it in your classes or schools. We are going to revise some important sections today. Okay. Hari, before we start, just confirm me from your end. Can you all hear me properly and see the video clearly? Confirm me from your end. All okay. Okay. Let's go to the YouTube. Zoom is full. Uh, I have a 500 capacity in the Zoom. Zoom is full. Sorry. YouTube. Sorry. Sorry. Right. I hope all of you have the tute with y'all. I already posted a tute for this session in your WhatsApp group. Already I posted a tute for this. I hope all of you have the tute. In case if you don't have the tute, at least have the PDF with y'all. And additional things you can write it in your separate book, whatever y'all have. Hurry. Without wasting any much time, we'll start because we have a lot of work to do. Maybe this session will go until about 11:30, 12. Maybe it will go after 12 as well, maybe, right? It depends on how much of work we finish per the time allocation we have, right? Hari, Ehinang, from your end, I want you all to have, if you have the tute, take the tute and get ready. Plus, if you have a writing book, not your normal class book or anything, a separate book to do sums or questions or anything, have a separate book with y'all and additional details, whatever I'm telling, other than the tute section. Or when I'm teaching, if I feel these sections can come for your exam, especially your term test, I will tell that. If so, to record them also have a separate book. Hurry, Enang, get ready with your tute, book and pen, pencil, whatever you have, and send me ready from your end once when you're ready. Get ready with the things and send me ready from your end. Hurry. So you are a bit dark. Dark never for that today. The lights are not working. Right? Hurry, hurry. Ready, ready. Perfect. Perfect. I think Lama, y'all came to do science here, learn to finish off chemistry, some important section for ionization energy, electronegativity, and we are doing quantification of elements and compounds, chemical bonds. I think don't be sleepy here, be active here throughout the session, from the beginning until the end. Be active, participate with me. When I tell something, repeat with me in your house. Tell, shout loud and repeat with me whatever things we are memorizing. Now here itself, we are memorizing whatever the calculation we are calculating. We are studying and finishing off the section. What are the section? First, ionization energy, electronegativity, quantification of elements and compounds, chemical bonds. I think we are not keeping those sections to study again. From today, by today, it's done. By tonight, it's done. Again, if you want, you can touch before your O-level exam. No need to touch. That way you are going to learn. So listen very carefully. You should feel that whatever I am telling, it goes inside your eyes, it goes inside your brain, it gets stored. That way, listen, I want laser focus from y'all. I want laser focus from y'all. So listen very carefully. Hurry. Right. I will start off with the last part of the tute. I'll start off with the last part of the tute, as all of y'all are having a lot of energy at the beginning. I'll start with the last part of the tute, that is quantification of elements and compounds. We'll first finish quantification, then we'll go to the other sections, right? Quantification of elements and compounds. Separate, nice lesson, right? What is this quantification means? Quantification, quantity, that means we are dealing with numbers. Remember, in chemistry, we have qualitative analysis, quantitative analysis. Qualitative, we discuss about the qualities. This is a metal, this is a non-metal. This metal has these kinds of properties. It can conduct electricity. Its boiling point is high, its melting point is high. Those are qualitative analysis. This is quantity, quantitative analysis. That means we are going to talk about numbers. Basically, we are going to analyze elements and compounds using numbers. Quantitatively, we are going to analyze elements and compounds. Now, when I tell about numbers, quantities, first quantity that comes into your mind is mass. First quantity that comes into your mind is mass. Hurry. Now, atoms. Atoms are very small, chuti particles. Molecules, even molecules are very small. My molecules are made of several atoms together, but still, they are also very small, very tiny. So, atoms and molecules are very small. So, what can you tell about their masses? Masses are also very small. You can express their masses in grams. But if you express it in grams, you get a very small number. You get a very tiny number. In 10 to the power negative values, you get the values. If you express the masses of atoms, molecules in grams, you get the values in 10 to the power minus values, which are very small. And it's very hard to do any calculations using those numbers. It's very hard to analyze those numbers. Therefore, in chemistry, we have made a separate method to analyze the masses of atoms and molecules. In chemistry, we have developed a separate method. There's a separate method to analyze the masses of elements and atoms and molecules. Give me a second, I'll plug the charger. So in chemistry, we have made a separate method to analyze the masses of atoms and molecules. What is that method? That is relative atomic mass and relative, listen now, focus here, relative molecular mass, relative atomic mass, relative molecular mass. In this, what's the concept we use? How we analyze the masses of atoms and molecules in relative atomic mass and relative molecular mass? This is the method. See, yeah? Alright. I'll explain it this way. In our school, let's take, there is a person A. What is this person's mass? 100 kilogram. Adiyappa. That's another person. He is 150 kilograms. This fellow is 100 kilogram, person A. This fellow, person B, is 150 kilogram. Another fellow is there, person C. This fellow is 50 kilograms. A is 100, B is 150, C is 50 kilograms. Now, instead of telling A is 100 kilograms, I can even tell like this, neither. A is 2 times the mass of C. Agree? A is 2 times the mass of C. A is 100 kilogram. 100 kilograms is 2 times 50. 2 times the mass of C. B is B is 3 times the mass of C. B is 3 times the mass of C. C is 50 kilogram. B is 150 kilogram. Then B is 3 times C. B is 3 times the mass of C. A is 2 times the mass of C. That way I can tell. What I have done here, I have compared the mass of A, mass of B with a common mass. I have compared the mass of A, mass of B with a common mass. Common mass is C, 150 kilogram. I have compared A with C 2 times, B with C 3 times. How did I get 2 times here? How did I get 2 times? What is the numerical mathematical calculation behind this? How did I get 2 times? C is 50 kilogram. That 50, using that 50, I divided the mass of A. A is 100. 100 divided by 50 2 times. How did I get 3 times here? How did I get 3 times here? C is 50 kilogram. Using that 50, I divided the mass of B, 150. So mass of a person divided by a common mass gives how many times that person's mass is. Mass of a person divided by common mass gives us how many times that person's mass is. This is the concept we use in relative atomic mass and relative molecular mass as well. In relative atomic mass and relative molecular mass, instead of telling directly the mass of a certain atom or mass of a certain molecule, we compare. We compare and tell how many times the mass is compared to that common value. How many times that mass is compared to that common value. So basically in relative atomic mass and relative molecular mass, we compare. We compare the mass of an atom with a common mass. We compare the mass of a molecule with common mass. That's the logic there. Nothing big. Basically, you are comparing. Now, to compare like that, Lamai, first of all, you need a common mass. Without a common mass, can I just compare? Can I just tell A is 2 times? No. A is 2 times of what? C. B is 3 times. 3 times of what? See, A can, first of all, I need a common mass. For this concept, I need a common mass. That is where your atomic mass unit comes into play. Or AMU can AMU and solo atomic mass unit. This is the common mass. Simply think like AMU is your C. That is your common mass that we are going to use to compare. That is your common mass that we are going to use to compare. That's the mass of C. Just think. All right. What is this atomic mass unit? What is this atomic mass unit? Atomic mass unit is 1/12 into mass of carbon 612 atom. Or even you can write it mass of carbon 612 atom divided by 12. Both are same. No? AMU is 1 over 12 into mass of carbon 612 atom. That is mass of carbon 612 atom divided by 12. What does this mean? What does this mean? See, you take a carbon 612 atom. 612 කියන්නේ atomic number 6, mass number 12. So you take a carbon 612 atom. Carbon 612 atom is very big. Tadi batalagedi. Carbon 612 atom. If the comparing mass is very big, if C is very big, can we compare? Tell me. Can we compare? If the comparing mass is very big, 30 batalagedi C person. Can we compare? No, we can't. So carbon 612 is very big. Its mass is very big. Then we can't compare. So what did the scientists do? They took carbon, cut it. They cut it. Cut it into how many pieces? 12 pieces. They cut it into 12 pieces. And took one piece out. Now tell me, carbon is big. Carbon 612 is big. If I cut it into 12 pieces and take just one piece out, is that piece that big? Is that mass that big mass? No. That mass will be small enough for us to compare. And this is the mass we are going to use to compare. This is our C. This is the mass we are going to use to compare. You take a carbon 612, cut it into 12 pieces, take one piece out. That is your common mass. That is C. Using that only you are going to compare. And this piece mass is called as atomic mass unit. You take a carbon 612 atom, cut it into 12 pieces, take a piece. Tell me that mathematically. You take a cake, cut it into 12 pieces, take one piece. How do you express it mathematically? How do you express it mathematically? 1 over 12. And 1 over 12 of means multiplication of the mass of carbon 612 atom is atomic mass unit. Make sense? Don't memorize these things. 1 over 12. That is the one piece from the 12. Of the mass of carbon 612 atom. Of the mass of carbon 612 atom is atomic mass unit. Don't think much about atomic mass unit. That is the unit we are going to use to compare. That is our C. So instead of this fellow, think now he is atomic mass unit. This fellow is atomic mass unit. How did you get atomic mass unit? You took a carbon, cut it into 12 pieces, took one piece out. Again, tell me, how did you get atomic mass unit? You took a carbon. What carbon? Carbon 612. You took a carbon 612, cut it into 12 pieces, took one piece. Now tell it mathematically. 1 over 12 into mass of carbon 612 atom. And repeat with me. Atomic mass unit is 1 over 12 into mass of carbon 612 atom. Again, repeat with me. Atomic mass unit is 1 over 12 into mass of carbon 612 atom. Don't forget it. Don't forget it. Until O level, you are not forgetting it. 1 over 12 into mass of carbon 612 atom. Sorry, that is atomic mass unit. Now the common mass is ready. Now we start comparing. Forget the letter C. Instead of C, hereafter I am going to use the word atomic mass unit. I won't use the word C. I'll be using atomic mass unit. Now A is how many times atomic mass unit? A is how many times atomic mass unit? 2 times. How did you get 2 times? How did you get 2 times? You took the mass of A, divided it by atomic mass unit, isn't it? You took the mass of A, you divided it by atomic mass unit. That is relative atomic mass. So in relative atomic mass, what do? You take an atom, you divide its mass by atomic mass unit. So when you divide it, you are getting how many times that atom is when compared to the mass of atomic mass unit. How many times that atom is when compared to atomic mass unit. In relative molecular mass, what you are doing? You are taking the mass of a molecule, dividing it by atomic mass unit. You divide the mass, so you take the mass of a molecule, divide it by atomic mass unit. So what is relative atomic mass? What is relative atomic mass? Nothing big. Relative atomic mass is you take the mass of an atom, divide it by atomic mass unit. Then you get how many times the mass of atom is when compared to this unit. How do you find relative molecular mass? Relative molecular mass is mass of a molecule. Mass of a molecule divided by atomic mass unit. What is atomic mass unit? I already told you. 1 over 12 into mass of carbon 612 atom. Atomic mass unit is 1 over 12 into carbon 612 atom. So instead of writing AMU, even I can write 1 over 12 into mass of carbon 612. Even I can write like that. This is atomic mass unit. Here also, instead of writing AMU, I can write 1 over 12 into mass of carbon 612 atom. You take the mass of an atom, divide by atomic mass unit. Then you get how many times the mass of that atom is when compared to atomic mass unit. When you are calculating relative molecular mass, you take the mass of a molecule divided by atomic mass unit. Then you get how many times the mass of that molecule when compared to atomic mass unit. Basically, what you are doing is comparison. How many times comparison? Okay. Understood? Yes. Yes. Perfect. Clear. Clear. All right. Clear, no? Right. Second, one more time. One more time. Now you memorize. Now you memorize. Finish off. Right. Atomic mass unit. Open the mouth and tell louder. Atomic mass unit equal 1 over 12 into mass of carbon 612 atom. Relative atomic mass. Relative atomic mass is mass of an atom divided by atomic mass unit. Relative molecular mass. Relative molecular mass. Relative molecular mass is mass of a molecule divided by atomic mass unit. One more time. Tell loud. Now you memorize. Atomic mass unit 1 over 12 into mass of carbon 612 atom. Relative atomic mass. Mass of an atom divided by atomic mass unit. Relative molecular mass. Mass of a molecule divided by atomic mass. Basically, you compare. Okay. Now, you all tell me, will we have any unit for relative atomic mass, relative molecular mass? Will we have any unit? Can I give any unit? No. Remember, a relative atomic mass, no unit. It doesn't have any unit. Relative molecular mass, no unit. It doesn't have any unit. Why am I no unit? Why am I no unit? Think about the logic. What is our logic? We are comparing. Mass of A is 2 times the mass of C. 2 times. Can I tell 2 grams? 2 kilograms? No. I can't. I can't give a unit there. 2 times unitless. 3 times unitless. Comparison is unitless. You can't give a unit for comparing. Just 2 times, 3 times, 10 times, 40 times. Calcium is 40 times atomic mass unit. That's it. I can give a unit there. Sodium is 23 times atomic mass unit. Magnesium is 24 times atomic mass unit. You don't need to write times there now. Now you don't catch the word times and start writing times. No need to write anything. If I tell calcium's relative atomic mass is 40, that's it. Calcium's relative atomic mass is 40. That's it. No need to put grams, kilogram, nothing. Relative atomic mass. එතකොට ළමයි we put gram per mole, this unit. Somewhere this unit comes from. What is that? Use gram per mole, there is a unit. For what we use gram per mole? That is used for molar mass. For molar mass, capital M. For molar mass only we put the unit gram per mole. How you get the molar mass? For relative atomic mass, if you put gram per mole, molar mass. For relative molecular mass, if you put gram per mole, molar mass. You take relative atomic mass or relative molecular mass, put the unit gram per mole to it. Now these are unitless. For that you are putting a unit gram per mole. If you put gram per mole, it is molar. It's molar. Again I repeat, relative atomic mass, relative molecular mass are unitless. No unit. But if you put the unit gram per mole, it is molar mass. Relative atomic and relative molecular mass are unitless. If you put gram per mole, it's molar mass. These things are not there in the tute. While I'm teaching, I'm telling and going. So if you want additionally, you can write and keep. Relative atomic mass, relative molecular mass are unitless. If you put the unit gram per mole, it is molar mass. It is molar mass. It's molar mass. Okay. Next. Mole concept. Mole concept. And sir, what is mole? It's a quantity used to measure the amount of substance. A quantity that is used to measure amount of substance is mole. Again, it's a standard quantity. It doesn't only come in chemistry. A quantity that is used to measure, used to represent the amount of substance. Amount of substance is mole. How to calculate mole? By now you should know this. Number of mole. You symbolize it as simple N. Number of mole equal given mass divided by molar mass. Again, number of moles equal given mass divided by molar mass. Number of moles is given mass divided by molar mass. Just to start your engine, we'll do one question with this. I know you can do questions. Most of you, you should be able to do question. Just to start your engine, just to revise this equation, we'll do one question on. Calculate the number of moles in 48 grams of magnesium. Within brackets, they give you magnesium's relative atomic mass is 24. Calculate the number of moles in 48 grams of magnesium. Magnesium's relative atomic mass is 24. How to do this question? Relative atomic mass is there 24. Relative atomic mass is 24 ki anni lamai. How much is the molar mass? You take the relative atomic mass 24, put the unit gram per mole, you have the molar mass. Calculate the number of moles in 48 grams. 48 grams, they are giving 48 grams. That is your given mass. 48 grams is your given mass. Given mass is there, molar mass is there. Can't you find the number of moles? Yes, you can. How? Apply the equation. Number of moles is equal to mass over molar mass. Mass is 48 grams. Molar mass is 24 gram per mole. From there, number of moles is 48 divided by 24. Anybody can do that math? No? 2 mole. 2 mole. Engine started. Yes. So will they ask the definition? එහෙම definition අහන්නේ මෙහෙමයි ළමයි. ඉපිට දැන් ගේපාන. They'll ask you, what is relative atomic mass? Rarely, eh? These questions are very rare. What is relative atomic mass? If so, you don't need to write sentences. What you need to write is relative atomic mass is equal to mass of an atom divided by, don't write AMU, atomic mass unit. You write the equation. Equation becomes the definition there. They might ask you, what is relative molecular mass? No need to write sentences. You can write mass of a molecule divided by, what did I write here? Atomic mass unit. Atomic mass unit. Or if you want to go one step ahead, you can 1 note L into mass of carbon 6 atom. That's what you write. That's what you write. Hurry, neither. Hurry. All these things are there in the tube. Whatever additional things I told you, you can write and keep the units there. What has unit, what doesn't have unit. Right? Whatever additional one, you can write it. Atomic mass unit is mass of carbon 6 atom divided by 12. Relative atomic mass, mass of an atom divided by, I wrote it in short, AMU. Relative molecular mass is mass of a molecule divided by AMU. How to calculate number of moles? Number of moles is mass divided by molar mass. Mass divided by molar mass. Onna puta, what you hate the most? Mr. Avogadro. Mr. Avogadro. Oh. Mr. Avogadro. Avogadro gave us a constant. Can remember the value? I have done these things, you all have done already. What's the value? Try to type and say. Avogadro constant 6.022 into 10 to the power 23. 6.022 into 10 to the power 23. Now, some fellows, when they see these powers, decimals, more scared. Can't understand what that number tells us. You should be able to identify now. Now, 10s and 11s, you should be able to identify. What does this number tells us? What do you mean by 6.022 into 10 to the power 23? What does this number mean? 6.022. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is the number. This is the number. Such a long number. I don't know how you pronounce it, how you read it. Unit zone, 1000 zone, million zone, billion zone, trillion zone, quadrillion zone. I don't know what comes after that. Chat GPT and find out what's the name. How can you read it? How can you read this number? This much of zeros. After quadrillion, another 2 times you have to jump. That big number, eh? Such a big number. 6.022 into 10 to the power 23. Such a big number. You put only 20 zeros. You. Only 20 zeros. No, we put why? 10 to the power 23. That 3 becomes 3 decimals. You jump 3 decimal. 1, 2, 3. Then you put 20 zeros. Multiply and see. That's math set. 23. You jump 3 decimals first. 3. Another 20 zeros you put. So that is a big number. Such a big number. Such a big number. Now, why this number is coming in our life? Why this big number is coming in our life? This is the thing, lah. This is the thing. Now listen. This is the thing. Listen very carefully. We learnt about moles. 2 mole, 1 mole, moles. Now I'm telling you, Buddha, go and bring me 1 mole of pens. I'm telling you, go and bring me 1 mole of pens, Atlas pens. Then what you do? You have to go and you have to count exactly 6.022 into 10 to the power 23 number of pens. If I ask you to bring 1 mole of pens, you have to exactly bring me 6.022 into 10 to the power 23 number of pens. That is that big number I wrote. That much number of pens, you have to slowly sit and put it in a container and bring me. I'm asking you to bring 1 mole of erasers. 1 mole of erasers. Then how many erasers you have to count and bring me? 6.022 into 10 to the power 23 number of erasers. That big number of erasers you have to count, again pack it in a container and bring me. I'm asking you to bring 1 mole of slippers. That is DSI slippers. I'm asking you to bring 1 mole of slippers. Then how many slippers you have to count and pack it in I don't know how many containers and bring? 6.022 into 10 to the power 23 number of slippers. I'm asking you to bring 1 mole of water bottles. How many water bottles you count and bring me? Now open the mouth and tell louder. How many water bottles you count and bring me? 6.022 into 10 to the power 23 number of water bottles. I'm asking you to bring 1 mole of books. How many books you have to count and pack and bring me? 6.022 into 10 to the power 23 number of books. I'm asking you to bring 1 mole of atoms. Then how many atoms you have to count, pack and bring me? 6.022 into 10 to the power 23 number of atoms. I'm asking you to bring 1 mole of molecules. How many molecules you have to count and bring me? 6.022 into 10 to the power 23 number of molecules. Understand the logic now? I am asking you to bring 1 mole of hydrogen atoms, 1 mole of H atoms. Then how many H atoms, hydrogen atoms you have to sit and count and bring me? 6.022 into 10 to the power 23 number of hydrogen atoms. That big number you have to count, you have to put it inside a, I don't know, a cylinder or something and bring me. I am asking you to bring 1 mole of O atom. What is O atom? Oxygen atoms. Then how many oxygen atoms you have to sit and count and bring me? Open the mouth and tell louder. 6.022 into 10 to the power 23 number of oxygen atoms. I am asking you to bring 1 mole of magnesium. Magnesium atoms. Then how many magnesium atoms you have to count and bring me? Give me 1 second. I'm asking you to bring 1 mole of magnesium atoms. Then how many magnesium atoms you have to sit and count and bring me? 6.022 into 10 to the power 23 number of magnesium atoms. I'm asking you to bring 1 mole of water molecules. Water is a molecule. Water molecules. Then how many water molecules you have to count and put it maybe inside a big tank or something and bring me? 6.022 into 10 to the power 23 number of water molecules. I'm asking you to bring 1 mole of calcium carbonate. Calcium carbonate molecules. How many calcium carbonate molecules you have to count and bring me? 6.022 into 10 to the power 23. That means what? What does this logic mean? What does this logic mean? 1 mole of any substance contain 6.022 into 10 to the power 23 number of substances in it. 1 mole of any substance contain 6.022 into 10 to the power 23 number of substances in it. Now here we are talking about chemistry. So here we discuss about atoms and molecules. That means 1 mole of atoms has 6.022 into 10 to the power 23 number of atoms. 1 mole of molecules has 6.022 into 10 to the power 23 number of molecules. Simple. That is Avogadro constant. So what is Avogadro constant? Number of substance in 1 mole of a certain substance. Number of substance in 1 mole of a certain substance. 1 mole of oxygen has 6.022 into 10 to the power 23 number of oxygen atoms. 1 mole of hydrogen has 6.022 into 10 to the power 23 number of hydrogen atoms. 1 mole of nitrogen has 6.022 into 10 to the power 23 number of nitrogen atoms. 1 mole of water molecules has 6.022 into 10 to the power 23 number of water molecules. 1 mole of calcium carbonate has 6.022 into 10 to the power 23 number of calcium carbonate molecules. 1 mole has this much of substances. It's like this. See, for some special numbers, we give some special names. For example, a pair. A pair can one pair. No? A pair means how many substances should be there? A pair means how many substances should be there? Every I think get up. What are you doing now? You're grade 10, grade 11. Don't sleep now. A pair means how many substances should be there? 2. A dozen. A dozen can be 1 dozen. A dozen means how many substances in it? A dozen, how many substances in it? 12. ඒ වගේමයි. A mole කියන්නේ ළමයි. A mole කියන්නේ, I'll write it in unit. A mole කියන්නේ 6.022 into 10 to the power 23. ඒ කියන්නේ 6022 000. That's it. A pair is 2, a dozen is 12, a mole 6.022 into 10 to the power 23. If I ask you to bring a pair of hydrogen, how many hydrogen atoms you will bring? 2 hydrogen atoms. If I ask you to bring a dozen of hydrogen, then how many hydrogen atoms you will bring? 12 hydrogen atoms. If I ask you to bring a mole of hydrogen atom, how many hydrogen atoms you have to bring? 6.022 into 10 to the power 23 number of hydrogen atoms. Understood? I think no forgetting again until O levels. Tonight we are finishing this. Okay. So basically I can tell 1 mole is 6.022 into 10 to the power 23 number of atoms or molecules. This number is called Avogadro constant because that fellow didn't have any work for several years, more than about 20 years. He was working on this and he finally found that 1 mole means 6.022 into 10 to the power 23 number of atoms. 1 mole of molecule means 6.022 into 10 to the power 23 number of molecules. He found. That fellow found. Now we are suffering. That's logic there. Everything in science, maths history, everything is like that. Some fellow works their whole life and finds something. We have to study it throughout our life. Right. Now this part clear? 1 mole is this much number. Clear? Yes? Okay. Alright, perfect. I'll go one more step ahead. Now for theory students, these things are done in the theory. And special grade 10 students. Recently we did it. Now listen, back to the track. Listen. If I ask you to bring 1 mole of oxygen atoms, how many oxygen atoms you will bring? 6.022 into 10 to the power 23 oxygen atoms. I take all those oxygen atoms, keep them on a weighing scale, measure the mass. The mass will be exactly 16 grams. If I ask you to bring 1 mole of hydrogen atom, how many hydrogen atoms you will bring? 6.022 into about 23 number of hydrogen atoms. Take all of them. Keep them on a weighing scale. Measure the mass. Mass is exactly 1 gram. How's the magic? If I ask you to bring 1 mole of magnesium atoms, will exactly count and bring 6.022 into 10 to the power 23 number of magnesium atoms. I take, keep them on a weighing scale, measure the mass. Mass is exactly 4. Never 24. 24 grams. Exactly 24 grams. Not less, not more. Exactly. If you take the count properly, it's exactly 24 grams. I ask you to bring 1 mole of water molecules. Let's say you are bringing, how are you bringing? You are counting 6.022 into 10 to the power 23 number of water molecules. Let's say you are packing it inside my water bottle and you are giving me. I keep this on the weighing scale. I measure the mass. Mass is exactly 18 grams. I ask you to bring 1 mole of calcium carbonate molecules. Now you are going searching everywhere. You are counting 6.022 into 10 to the power 23 number of calcium carbonate molecules. Packing them in a goni bag. Taking and bringing me and giving me. I keep it on a weighing scale. I measure the mass. Exactly. Your science marks in grams will come. 100 grams will come. Now guess and tell me, these are atoms, oxygen atom, hydrogen atom, magnesium atom. What is 16 in oxygen? By now you should have come across this 16. What is 1 in hydrogen? What is 24? Just now we did a question also for magnesium. What is this 24? What is 16? What is 1? What is 24? Relative atomic mass. Relative atomic mass of oxygen is 16. Relative atomic mass of hydrogen is 1. Relative atomic mass of magnesium is 25. I told you, they don't have a unit. Relative atomic masses, they don't have unit. So 16. I'm not talking about the unit here. Don't look at the unit. 16 is the relative atomic mass of oxygen. 1 is the relative atomic mass of hydrogen. 24 is the relative atomic mass of magnesium. What is 18? With experience, tell me, you should have done questions. 18 for water, 100 for calcium carbonate. What is that? What is that? Relative molecular mass. Relative molecular mass of what is 18? Relative molecular mass of calcium carbonate is 100. So these are relative molecular masses. These are relative atomic masses. Relative atomic mass, relative molecular mass, they don't have a unit. But here can you see, I have given a unit. I have given a unit. What's the unit I have given? Grams. That means I can tell, listen, now the last connection. That means I can tell 1 mole of a substance contain 6.022 into 10 to the power 23 number of atoms or molecules. That is also equal to relative atomic mass or relative molecular mass in grams. This is also equal to relative atomic mass if it is an atom, relative molecular mass if it is a molecule in grams. Harinelamine C, 1 mole of oxygen atoms contain 6.022 into 10 to the power 23 number of oxygen atoms. That is also equal to 16. That is relative atomic mass of oxygen in grams, 16 grams. 1 mole of hydrogen atom contains 6.022 into 10 to the power 23 number of hydrogen atoms. That is also equal to 1. 1 is a relative atomic mass, grams. 1 mole of magnesium contains 6.022 into 10 to the power 23 number of magnesium atoms. That is also equal to 24. 24 is the relative atomic mass of magnesium, 24 grams. Not only atoms, come to the molecule side. 1 mole of water has 6.022 into 10 to the power 23 number of water molecules. That is also equal to 18. 18 is the relative molecular mass, grams. 1 mole of calcium carbonate contains 6.022 into 10 to the power 23 number of calcium carbonate molecules. That is also equal to 100. 100 is the relative molecular mass of calcium carbonate, grams in grams. So that gives us a triplet equation. A triplet equation. What is our triplet equation? What is our triplet equation? 1 mole is equal to 6.022 into 10 to the power 23 number of substances. That is also equal to relative atomic mass or relative molecular mass in grams. For example, for example, relative atomic mass of sodium is 23. Relative atomic mass of sodium is 23. Now you are going to help me, eh? You are going to help me. I am asking you, Puta, go and bring me 1 mole of sodium. How many sodium atoms you have to count and bring me? Type and send, type and send. I think you all type so many messages. No? Type this and send me. Mm, 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 mm. 6.022 into 10 to the power 23 sodium atoms. I put it in a weighing scale, measure the mass. What's the mass? Tell me with the unit. I think you don't just in the number. I don't want numbers here. I want with the unit. Grams, kilograms, what? 23 grams. Okay. Another one. We'll take for calcium. Relative atomic mass 40. 1 mole of calcium How many calcium atoms are there? 6.022 into 10 to the power 23 calcium atoms. I put it in a weighing scale, measure the mass. What's the mass? What's the mass? Perfect. 40 grams. 40 grams. We'll do for molecule. What molecule will take? Gamukulamai magnesium oxide. 24 plus 16. Relative molecular mass of magnesium oxide is 40. Magnesium oxide relative molecular mass is 40. Tell me the logic. 1 mole of magnesium oxide. How many magnesium oxide molecules will be there? Now we talk about molecules. How many molecules? 6.022 into 10 to the power 23 magnesium oxide molecules. What's the mass? What's the mass? All participate here. You are in this session for past 1 hour. Now you should answer this question. Otherwise, you are wasting your time. Don't do that. Do good for your time. Again, you are getting the same value. Need be 40 grams. It will be 40 grams. Okay. Understood the triplet equation now? Yes. Yes. Now relate it with molar mass and see. What is the molar mass of sodium? What's the molar mass of sodium? What's the molar mass of sodium? Molar mass of sodium. 23 gram per mole. What do you mean by 23 gram per mole? There are 23 grams in 1 mole. Harini. That is Avogadro constant telling. There are 23 grams in 1 mole. That is what you mean by 23 gram per mole. And that is why unit for molar mass is, where's that? Unit for molar mass is gram per mole. You take the relative atomic mass, you take the relative molecular mass, put gram in 1 mole, gram per mole. That is molar mass. Understood the concepts now? You take the relative atomic mass, you take the relative molecular mass. For that, you put grams. That is there in 1 mole, gram per mole. That is molar mass. Clear with the connections? And that will be equal to 6.022 into 10 to the power 23 number of substances. Those are the logics. Those are the logics. One more point. Now in the exam, if they ask you to write the Avogadro constant, they won't ask you to write the Avogadro constant. Maybe there is an MCQ question. Which of the following is Avogadro constant? What is your answer? Are you going to just write 6.022 into 10 to the power 23? If they ask you the Avogadro constant. Are you going to just write 6.022 into 10 to the power 23? No. If you write it, you are wrong. It will surely put wrong. You can't write only this. Remember, Avogadro constant as a unit. Unit for Avogadro constant is per mole. MOL to the power minus 1. Per mole. And this is Avogadro constant. 6.022 into 10 to the power 23 per mole. What do you mean by per mole? 1 mole. In 1 mole, there is 6.022 into 10 to the power 23 number of substances. Harini? In 1 where? Where? In 1 mole, there is 6.022 into 10 to the power 23 number of substances. So 6.022 into 10 to the power 23 per mole. Per mole. This should be indicated. This is the unit for Avogadro constant. Keep that in mind. That is the unit. That's the unit for Avogadro constant. Okay. Hurry. Almost the quantification of elements and compounds is done. Only one small section is there for me to teach you all. Before that, we'll go to the tute. Avogadro constant value. 6.022 into 10 to the power 23 unit per mole. Under that, in that box, we'll write that equation and keep 1 mole, write with me, 1 mole is equal to 6.022 into 10 to the power 23 atoms or molecules, that is also equal to relative atomic mass or relative molecular mass in grams. Write this equation and keep. Work, don't just stay. Should we memorize the molar masses? No need. They will give in the exam. But I would tell it's better to know them. It saves time in your exam, special calculations. Okay. Under that, we'll just write one and keep, write one example and keep. 1 mole sodium is equal to 6.022 into 10 to the power 23 sodium atoms. That is also equal to 23 grams. Just write one example and keep. Example. Okay, no? Hurry. Another one more small part is there, but we can start some questions. Hurry. Take the question 1 there. Do with me, eh? Take the question 1. Right. Do faster than me. Consider 500 grams of calcium carbonate. Calcium carbonate. Calcium carbonate. First, you need the formula of calcium carbonate. What is calcium carbonate? Calcium is Ca, carbonate is CO3 minus 2, calcium valency 2, group 2, carbonate valency 2, 2, 2 valency, no need to write them. Then the formula is CaCO3. By now, you should be able to write formulas CaCO3, right? So they are talking about CaCO3. Consider 500 grams of calcium carbonate. 500 grams of calcium carbonate. This is the given mass. Calcium relative atomic mass is there, carbon relative atomic mass is there, oxygen relative atomic mass is there. How many moles are present? They are asking number of moles. They are asking number of moles. We have given mass. They are asking number of moles. For that, first you need the molar mass. First you need the molar mass. First you need the molar mass. Given mass is 500 grams. You need the molar mass. They are given calcium 40, oxygen 16, carbon 12. We'll calculate the molar mass. Molar mass of calcium carbonate. Calcium is 40 plus carbon. Carbon is 12 plus 1 oxygen. 1 oxygen is 16. How many oxygen are there? 3 oxygen are there. Multiply by 3. If I do the math, 16 into 3, 48. 48 plus 12, 60. 60 plus 40, 100. Molar mass is G mole to the power minus 1. 100 gram per mole. I have the molar mass. I have the given mass. What are they asking? What are they asking? How many moles are present? How many moles are present? How to calculate? Number of moles is equal to given mass divided by molar mass. What is the given mass here? 500 grams. What is the molar mass here? 100 gram per mole. 500 divided by 100, how much? 5 mole. 5 mole. Simple question, eh? First one is a very simple question. 500 moles. Sorry, 5 moles. Five moles. Right. Going to question 2. What is question 2 asking? How many molecules are present? How many molecules are present? How many molecules are present? Onnalamai. What's the logic? What's the logic? What's the logic? What is the logic? What is the logic? Tell me. 1 mole, how many molecules are there? In 1 mole, how many molecules are there? 6.022 into 10 to the power 23 molecules. In 1 mole, there are 6.022 into 10 to the power 23 molecules. The logic is in 1. Now think practically. In 1 mole, in logic is in 1 mole there is 6.022 into 10 to the power 23. Now here how many moles are there? How many moles of calcium carbonate are there? How many moles? 5 moles. Now mathematically think. 1 mole 6.022 into 10 to the power 23. Ehinang, in 5 moles, how many molecules will be there? 1 mole 6.022 into 10 to the power 23. Then 5 moles, 5 into 6.022 into 10 to the power 23. Agree with the mathematical part I have done? 1 mole is 6.022 into 10 to the power 23. 5 moles is 5 into 6.022 into 10 to the power 23. 10 moles is 10 into 6.022 into 10 to the power 23. 15 moles is 15 into 6.022 into 10 to the power 23. 30 moles is 30 into 6.022 into 10 to the power 23. If you want, you can solve it, or you can keep it like this. This way you can keep. For this, you get marks. But write 10, keep the final answer. 5 into 6.022 into 10 to the power 23. Calcium carbonate molecules are there. This much of molecules. Or if you want, you can solve it. If you solve it, you'll get 30.22 into 5 is 110. 30.110 into 10 to the power 23. If you want, you can solve it. That's equal to 30.110 into 10 to the power 23. Both the answers are correct. Yeah, solving doesn't make any changes to your marks. You can keep it like this. Unless and otherwise, it's a small number. Eh? Now, 2 into 6.022, solve it. 2 into 6.022, anybody can solve on 12.044. 3 into also solve. 4 into no need, 5 into no need. Usually what you get is 2, 3. If so, solve it. That's not hard. That's your answer. Correct. Now, third question, you can still do it. I'll explain. Third question, what is third question asking? What is third question asking? How many total numbers of atoms are present? How many total number of atoms? How to find that? How to find that? Now, what is the part I have taught you? What I have taught you until now? What I have taught you? 1 mole of atoms will have 1 mole of atoms will have 6.022 into 10 to the power 23 number of atoms. 1 mole of molecules will have 6.022 into 10 to the power 23 number of molecules. That's what I taught you. No? In 1 mole of atoms, there is exactly 6.022 into 10 to the power 23 number of atoms. In 1 mole of molecules, there is exactly 6.022 into 10 to the power 23 number of molecules. If you start with atoms, you finish with atoms. If you start with molecules, you finish with molecules. 1 mole of atoms has 6.022 into 10 to the power 23 number of atoms. 1 mole of molecules have 6.022 into 10 to the power 23 number of molecules. Now, what's the question asking? They are talking about calcium carbonate molecule. But they are asking how many atoms are there? They are talking about calcium carbonate molecules and they are asking how many atoms are there. From here to there, you have to go. They are talking about molecule. They are asking the number of atoms. Now, in this case, how do you solve the question? If they give you the number of molecules and they ask the number of atoms, how do you solve the question? If they give you the number of molecules and they ask the number of atoms, how do you solve the question? How do you solve the question? Actually, this one you have to logically answer. But I have an equation. You can use it. This equation, you can use it. By this equation, you can get the answer. How to find the number of atoms when number of molecules are given in molecule? How to find the number of atoms in molecules? How to find number of atoms in molecules? Very simple. Number of atoms in molecules is equal to number of molecules multiplied by number of atoms in one molecule. What? You won't understand initially. First, look at the equation. Number of atoms in molecule is equal to number of molecules multiplied by number of atoms in one molecule. Repeat with me louder. Number of atoms in molecules equal number of molecules multiplied by number of atoms in one molecule. One more time, louder. Now you memorize this. Number of atoms in molecule equal number of molecules multiplied by number of atoms in one molecule. That means See, let's take, they are asking in 1 mole of water, how, in 1 mole of water molecules, how many atoms are present? In 1 mole of water molecules, how many atoms are present? How many atoms are present? See, they have given the number of molecules. They are asking the number of atoms. How do you solve the question? This equation. Number of atoms in molecules equal number of molecules multiplied by number of atoms in one molecule. See, 1 mole of water molecule. 1 mole of water molecule. First tell me, Lamai, in 1 mole of water, how many water molecules are present? In 1 mole of water, how many water molecules are present? That is what we were discussing all this time. In 1 mole of water, how many water molecules are there? In 1 mole of water, how many water molecules are there? How many water molecules? That's what we were discussing all this time. In 1 mole of water, how many water molecules are there? If I ask you to bring 1 mole of water, how many water molecules you have to count and bring me? Everyone, type that number. If I ask you to bring 1 mole of water, how many water molecules you have to count and bring me? 6.022 into 10 to the power 23. 1 mole of water has 6.022 into 10 to the power 23 water molecules. Water molecules. These are molecules. Water molecules. Are they asking molecules? No. They are asking atoms. They are not interested about the number of molecules. What they are interested is number of atoms. Now, how to find the number of atoms here? How to find the number of atoms? Use the equation. Number of atoms in molecule is equal to number of molecules. How many molecules are there? 6.022 into 10 to the power 23. 6.022 into 10 to the power 23 molecules are there. Number of molecules multiplied by number of atoms in one molecule. One molecule. Look at one water molecule. One single water molecule. How many atoms are there? Count and tell me. 2 hydrogen, 1 oxygen. Altogether, how many atoms? In one water molecule, how many atoms are there? 3 atoms are there. 2 hydrogen, 1 oxygen, then altogether there are 3 atoms. 3 atoms. So number of atoms in one molecule is 3. You multiply it by 3. Number of molecules multiplied by number of atoms in one molecule. That gives you total number of atoms. Number of molecules multiplied by number of atoms in one molecule. So if I multiply 3 into 6.022 into 10 to the power 23 is 18.066 into 10 to the power 23 atoms are present. See how I did the calculation? How I did the calculation? They are telling 1 mole of water molecule. How many atoms are present? What's the logic? 1 mole of water contains 6.022 into 10 to the power 23 water. They are not asking water, they are asking atoms. The number of atoms in one molecule is equal to, number of atoms in molecule is equal to number of molecules multiplied by number of atoms in one molecule. Number of molecules is 6.022 into 10 to the power 23. That multiplied by number of atoms in one molecule. In one molecule, 3 atoms are there, multiplied by 3. Now, if they talk about ammonia, NH3, then you multiply by what? How many atoms are there in one molecule of ammonia? 6.022 should be multiplied by how much? Then you multiply by 4. Because NH3 is altogether 4 atoms are there. If they talk about ammonia, you multiply by 4. If they talk about calcium carbonate, then you multiply by count and tell me 5. Our last multiplication will only change. Up to here, you use Avogadro constant. Then you multiply by number of atoms in one molecule. You multiply by 5. Simply, it's like this. Now, this story, even in theory class, I used to tell when I'm teaching this section. Just think, one bath parcel. One bath parcel has 3 chicken leg piece. Super bath parcel. Ne? One bath parcel has 3 chicken leg piece. Hinang tell me 2 bath parcel. How many chicken leg pieces? Now don't ask me where. One bath parcel, 3 leg piece nang 2 bath parcel. How many? More simple question. Eh? 1 bath parcel, 3 leg piece. 2 bath parcel. How much? How much? 6. How did you get 6? What's the maths behind it? How did you get 6? How do you get 6? 2 multiplied by 3. What is 2? Number of bath parcel. Number of bath parcel. What is 3? Number of legs in one bath parcel. Number of legs in one bath parcel. Number of bath parcel multiplied by number of legs in one bath parcel gives the total number of legs. Agree? Number of bath parcel multiplied by number of legs in one bath parcel gives the total number of legs. Now convert it into chemistry. One water molecule has 3 atoms. One water molecule has 3 atoms. Just think like 3 chicken leg pieces. Henang tell me 2 water molecules. How many atoms? 6. How did you get 6? 2 multiplied by 3. What is 2 multiplied by 3? 2 is the number of molecules multiplied by 3 is the number of atoms in one molecule. 5 water molecules. How many atoms are there? 5 water molecules. How many atoms are there? Think like bath parcel. 5 bath parcel. How many leg pieces? 15. How did you get 15? Number of water molecules 5 multiplied by number of atoms in one molecule. One molecule is 3. 15. 1000 water molecules. 1000 water molecules. How many atoms are there? 3000. How did you get 3000? Number of molecules 1000 multiplied by number of atoms in one molecule 3. 6.022 into 10 to the power 23 water molecules. 6.022 into 10 to the power 23 water molecules. How many atoms are there? How many atoms are there? Think like bath parcel. This much of bath parcel. How many atoms are there? This number multiplied by 3. What's the logic here? Number of molecules multiplied by number of atoms in one molecule. Number of molecules multiplied by number of atoms in one molecule. That's the logic. number of molecules multiplied by number of atoms in one molecule. You think like a birth person. Now in the tube, how to calculate the number of atoms present in a given moles of molecule? Under that, in this box, write this equation. This one, upper one, the one that I boxed. Okay. Now go to Roman number 3. Now go to Roman number 3. How many total number of atoms are present? You already calculate how many molecules are present. Now they are asking how many atoms are there. In what? Calcium carbonate. How to do the question? How to do the question? We already know the number of molecules. This full red thing is the number of molecules. Neither. නැත්තම් කියන්න බලන්න 30 into 1.00 30.110 into 10 to the power 23. That is the number of molecules. This, remember, listen to this very carefully. Yeah? This full red part is number of molecules. They are not asking number of molecules. They are asking number of atoms. How to find number of atoms is equal to number of molecules multiplied by number of atoms in one molecule. How many molecules are there? This red thing is the number of molecules. What is the red thing? 5 into 6.022 into 10 to the power 23. This is number of molecules. That full thing you have to multiply by number of atoms in one molecule. Number of atoms in one molecule. Tell me, calcium carbonate, one single molecule. Count and tell me how many atoms are there? How many atoms are there? Calcium 1, carbon 2, oxygen 3 are there. 2 plus 3, 5. Then you multiply this by 5. That number of atoms are there. Remember the differences here. This 5 came from moles, or 5 moles. 5 into 6.022 into 10 to the power 23 is number of molecules. That thing you multiplied by 5. 5 is the number of atoms in one molecule. That gives you total number of molecules. So if I do the math there, that gives us, maybe I can multiply these two and keep 25 into 6.022 into 10 to the power 23 atoms. Or even you can put 30. Now some asking, can we put 30.110? No problem. Right? 30.11022 into 10 to the power 23. Sorry, 30.110 into 10 to the power 23. No problem. Now instead of red one, even you can write this one here. Both are same. No? Then if you want, you can multiply or you can keep it as it is. Now, once when you multiply, the final value should be this one final value. Now 25 multiplied by this one will have a final value. No? That value and your value should tally. Okay, remember why we are multiplying by what numbers? This 5 already came, it's already there. This 5 is already there from number of moles. 6.022 is there, 23 is there. That is number of molecules. Red part is the number of molecules. Multiplied by 5, why 5? Calcium carbonate has 5 atoms. You multiply by 5. Right? That's how you find the number of atoms. That's how you find the number of atoms. Now go to the next question. Go to the next question. How many calcium atoms are present? Yappa. Now they are asking only about calcium. Before they generally ask totally how many atoms are there. Now they are asking only calcium. How many calcium atoms are there? They are pinpointing to calcium. Now how you do the question? Nothing to worry. Same equation you use. What's the equation? Number of atoms in molecules is equal to number of molecules multiplied by number of atoms in one molecule. Before we apply the equation to total number of atoms. Now we are pinpointing. Now we are pinpointing only to calcium. Apply the equation only to calcium now. Only to calcium, you are going to apply the equation. How? See, number of calcium atoms. Same equation. Number of atoms is equal to number of molecules multiplied by number of atoms in one molecule. Tell me how many molecules are there? That is that red part. How many molecules are there? 5 into 6.022 into 10 to the power 23 molecules are there. So number of molecules are 5 into 6.022 into 10 to the power 23. This is number of molecules, red part. Multiplied by number of atoms in one molecule. Lamai, calcium carbonate. Now the question is pinpointed only to calcium. Tell me, in one calcium carbonate, how many calcium atoms are there? We only look at calcium now. Before we counted total. Now no total. We only look at calcium. How many calcium are there? How many calcium are there? Only one. Then you multiply by 1. If there's oxygen, then you multiply by. If there's oxygen, you multiply by 3. If there's total, you multiply by. If there's total, you multiply by 5. Understand the differences? Calcium nang 1. Carbon nang again 1. Oxygen you multiply by 3. Total you multiply by 5. That's it. That is quantification of elements and compounds. For this only you all were worrying all this time. Here you multiply by 1, which gives us the same answer. 30.110 into 10 to the power 10 to 3. Calcium atoms. Do the last 2 questions. You all do now? Next they are asking for carbon. Next they are asking for oxygen. Do work. Send me the answer for oxygen. Work. All of you work now. Don't just wait. Work on the other 2 questions. Others, if you have anything to write, look and write. Don't just wait here. Finish off the other 2 questions. Work. එකනේ ළමයි. You can see mic got off. Now they are asking how many carbon atoms are there. How many carbon atoms are there? Logic is the same. Number of carbon atoms is equal to number of molecules multiplied by number of atoms in one molecule. Number of molecules multiplied by number of atoms in one molecule. How many molecules are there? That is that red part. 5 into 6.022 into 10 to the power 23 molecules. This is molecules. This is the red part. Multiplied by number of atoms in one molecule. Look at 1 calcium carbonate. How many carbon are there? 1 carbon. Then you multiply by 1. That gives us the same answer, 30.110 into 10 to the power 23 carbon atoms. Sixth question. How many oxygen atoms are there? How many oxygen atoms are there? Logic is the same. Logic is the same. Number of O atoms. Oxygen atoms equal number of molecules. That is the red part. 5 into 6.022 into 10 to the power 23. Multiplied by number of atoms in one molecule. Number of atoms in one molecule. Calcium carbonate. One molecule, how many oxygen are there? 3 oxygen. You multiply by 3. Total you multiply by 4. Total you multiply by 5. Calcium you multiply by 1. Carbon you multiply by 1. Oxygen you multiply by 3. So here you multiply by 3. Whatever the mathematical part. After this, what's the mathematical part you want, you can do. 3 into 5 is 15 into 6.022 into 10 to the power 23 oxygen O atoms. So understand the logic. Total multiply by 5 for calcium carbonate. Calcium multiply by 1. Carbon multiply by 1. Oxygen multiply by 3. That's it. Now after that, maths, and these parts are maths. Now don't ask me, sir, how you got this. These are maths. These are mathematical parts. Raise the hand those who got this answer. Oxygen. Oxygen's answer. I simplify. No problem. You can simplify. This kind of answer you should have. 15 into 6.02 to what you get, that answer you should get. 90.33, no problem. I guess, yeah, 90.33 is what you get. No, 90. Is it 90? 15 into 6.0, no, not 90, 45 something. Right, good. හරි නේද? Do this MCQ 2019. MCQ. Relative atomic mass of iron is 56. What's the correct statement? They're asking about mole Avogadro constant. No? Hurry. Will build the relationship. Will build the relationship. This is a past paper question. Eh? 1 mole of iron will be equal to 6.022 into 10 to the power 23 iron atoms. That is also equal to 56 grams. That's the logic, no? 1 mole is 6.022 into 10 to the power 23 iron atoms. That is equal to 56 grams. What's the question telling? Relative atomic mass of iron is 56. Thus, which of the following statement is the correct statement? Mass of an iron atom 56 gram. Adeyappa. 1 iron is 56 grams, it seems. Pachappoi. One iron can't be 56 grams. Never. Wrong. Second one. A mole of iron, 1 mole of iron contains 56 iron atoms, it seems. Lamai, tell me, 1 mole has 56 iron atoms or 6.02 to 10 to the power 23 ions? 6.02 into 10 to the power 23 ions, not 56. Wrong, wrong. Boru kiyanne mewa. Third statement. Mass of 6.022 into 10 to the power 23 iron atom is 56 grams. Check that. Mass of 6.022 into 10 to the power 23 iron atoms is 56 grams. Correct or wrong? Mass of 6.022 into 10 to the power 23 iron atoms is 56 grams. That is correct. That statement is correct. Go to the fourth one. Mass of 56 iron atoms is 6.022 into 10 to the power 23 grams. You take 56 iron, the mass is 6.022 into 10 to the power 23 grams. It seems. Borune. Pachappoi. Wrong. Answer is answer 3. That's wrong. Answer 3. Come to 2018. Patta question. O-level question. This is O-level question. Y'all do? Total number of atoms in 1 mole of carbon dioxide. Last equation I taught you. That is applied. Total number of atoms in 1 mole of carbon dioxide. They're asking atoms. They are asking atoms. Atoms. Total number of atoms. 1 mole of carbon dioxide molecule. Molecule is given. Atoms is asked. All of you send the answer. Perfect. Very good. Very good. Total number of atoms in 1 mole of carbon dioxide. 1 mole of carbon dioxide. What's the logic I taught you? 1 mole of carbon dioxide contains 6.022 into 10 to the power 23 carbon dioxide molecules. Are they asking molecules? Nope. They are asking atoms. So you use the equation I taught you. Number of atoms is equal to number of molecules. That is this red color part. That's the number of molecules. Number of molecules 6.022 into 10 to the power 23 multiplied by number of atoms in 1 molecule. Tell me, 1 carbon dioxide. How many atoms are there? How many atoms are there? 3 atoms are there. You multiply by 3. See how nicely they give the answers. This is O-level paper. No need to solve. I told you, no need to solve these things. They nicely give the answer. What's your answer? 6.022 into 10 to the power 23 into 3. How much? What's the answer? First one is. First one is the answer. To the next question also. That's also 2018 O-level. What's the answer? The relative molecular mass of hormone adrenaline is 183. Relative molecular mass of adrenaline is 183. Now what's the equation? Relative molecular mass is mass of adrenaline molecule divided by atomic mass unit. What is atomic mass unit? What's the value of atomic mass unit? We already memorized. What's the value of atomic mass unit? What's the value? What's the value? Instead of atomic mass unit, what I can write? 1/12 into mass of carbon 612 atom. That's what they're asking, neither. X in the relationship. X is atomic mass unit, that is this. This is going to be X. 1/12 into mass of carbon 612 atom. What's the answer? 1/12 into mass of carbon 612 atom is this. That is this. Okay. Okay. One more time, revise with me. Open the mouth, tell louder, revise with me. Quantification of elements and compounds. Now we are finishing this. Quantification of elements and compounds. What are the logics? Atomic mass unit equal 1/12 into mass of carbon 612 atom. Second, relative atomic mass equal mass of an atom divided by atomic mass unit. Atomic mass unit is 1/12 into mass of carbon 612 atom. Relative molecular mass. Relative molecular mass is equal to mass of a molecule divided by atomic mass unit. Atomic mass unit is 1/12 into mass of carbon 612 atom. Tell me, relative atomic mass, relative molecular mass, do they have a unit? No, they don't have a unit. Next, coming to number of moles. Number of moles, simple N is equal to simple M, given mass divided by capital M, molar mass. What is capital M? Molar mass. How to find molar mass? You take the relative atomic mass, you take the relative molecular mass, put G mole to the power -1, gram per mole. Next, Avogadro constant. Avogadro constant is 6.022 into 10 to the power 23. Open the mouth and tell louder. 6.022 into 10 to the power 23. What does this Avogadro constant tells us? 1 mole of substance equal 6.022 into 10 to the power 23 atoms or molecules. That is also equal to relative atomic mass or relative molecular mass in grams. Okay. Finally, number of atoms in molecule is equal to number of molecules multiplied by number of atoms in one molecule. Okay. Clear? Is quantification of elements and compounds hard? Is it hard? With that same spirit, we'll go to the next part as well. This is the last part of the tube. I want to finish up. Go. Go me bonding part. We'll finish the chemical bonds, then I'll go to the first ionization and electronegativity. Chemical bonds. Onna listen, now sit properly. Keep your spine straight. Don't go to WhatsApp, not now. Come back. I'm telling to you, come back. Stay here. Sit properly. Keep your spine straight. Back with the energy. Don't feel down now. Back again, come up with the spirit now. Right. Chemical bonds. Listen, chemical bonds. We already know there are two types of bonds. What are the two types of bonds? Ionic bond, covalent. Covalent bond. Ionic bond and covalent bond. Ionic bond. If ions make bonds, ionic bond. If ions make bonds, ionic bond. Covalent bond. Covalent bond. If atoms share electron and make the bond, covalent bond. If atoms share electron and make the bond, covalent bond. So here sharing is happening. Sharing is happening. In ionic bond, ions are making the bond. Ions are making the bond. So bond is made by ions, ionic bond. Bond is made by sharing electron, covalent bond. When a compound makes ionic bond, you call it ionic compound. When a compound makes covalent bond, you call it covalent compound. Now, what are the ionic compounds we have and covalent compounds we have? How to memorize it? Don't go to memorize. I'll give a shortcut. What are the ionic compounds and covalent compounds we have in our syllabus? Don't memorize. I'll give a shortcut. Theory class students, I have given you all this. Periodic table. Hydrogen is there, helium is there, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Me periodic table. This is first group, second group, third group, fourth, fifth, sixth, seventh, eighth. Eighth group is also called as noble gases. We know that. Now, what is the shortcut I'm going to give you all? No need to memorize the ionic compounds and covalent compounds in our syllabus. For that only I'm giving the shortcut now. Now listen. After you draw the periodic table, draw a box. Draw a box. Lithium, sodium, potassium, beryllium, magnesium, calcium in one box. Oxygen, fluorine, sulfur, chlorine, another box. This is a box, that is another box. Remember, if a compound is formed by the combination of elements from this box and elements from this box. If a compound is formed by the combination of elements from this box and element from this box, both these boxes should combine. Both these boxes should combine. If both of them combine and form a compound, that compound is ionic. If both of them combine and form a compound, ionic compound. All other combinations are covalent. These two box combination is ionic. All other combinations are covalent. ඔන්න එහෙනම් tell me sodium chloride ionic the covalent. See, sodium from this box, chlorine from this box, both are joining what kind of compound? What kind of compound? Ionic compound. Ionic compound. Calcium oxide. Calcium oxide. Calcium from this box. Oxygen from this box. Both are joining. Ionic compound. Ionic compound. Potassium fluoride. Potassium fluoride. Potassium from this block, fluorine from this block, both are joining ionic. Now see. Methane, CH4. Carbon, out of the box. Hydrogen, out of the box. Even if one is out of the box, it's not ionic. Any other combination is covalent. Carbon is out of the box, covalent. Carbon dioxide. Carbon dioxide. See, Carbon. Carbon is out of the box. You will tell answer oxygen is inside the box. Doesn't matter. One is out of the box. Finish. Any other combination is covalent. Carbon is out of the box. Covalent. H2. H2. Two hydrogen are joining. Hydrogen is what? Out of the box. Covalent. O2. 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 O2 is covalent. What's the logic I taught you? This box and this box should join. There should be an element from this box. There should be an element from this box. Both of them join ionic. O2. Two oxygen are joining. Oxygen is from the same box. I told you, any other combination is covalent. O2 can both the oxygen are from the same box. No. Two boxes joining is ionic. Same box joining is other combinations. Covalent. Cl2. Think and answer me. Cl2. Cl2. Covalent. Block is joining. Sulfur dioxide. Sulfur dioxide. Sulfur dioxide. Sulfur from this block, oxygen from this block, both are in the same block. Wrong. Covalent. These two blocks joining is only ionic. Same block, covalent. So that is covalent. So using this shortcut, you can find out the ionic and covalent compounds. One more point. If you see any polyatomic ions in a compound, polyatomic ions means, can remember radicals? You all learnt in your third lesson, grade 10. Radicals, polyatomic ions. What is polyatomic ions? Several atoms with a charge. Can remember? -1 charge, nitrate, nitrite, NO3 minus, NO2 minus, permanganate, MnO4 minus, hydroxide, OH minus, bicarbonate, HCO3 minus, bisulfate, HSO4 minus, -2 charges, sulfate, SO4 2 minus, carbonate, CO3 2 minus, chromate, CrO4 2 minus, dichromate, Cr2O7 2 minus, -3 charge, phosphate, PO4 3 minus, +1 charge, hydronium, H3O plus, ammonium, NH4 plus, you have to memorize. Those are radicals. Those are polyatomic ions. Can remember. If you see any polyatomic ions in a compound, if a polyatomic ion is involved in a compound, then that is also ionic compound. If a polyatomic ion is involved in a compound, that is ionic compound. Harine, polyatomic ion is present, ionic. So if you see any polyatomic ion, ionic compound. Example, calcium carbonate. Lamai carbonate, CO3 2 minus, polyatomic ion, then calcium carbonate is a ionic compound. Sodium nitrate. Sodium nitrate. Nitrate, NO3 minus. NO3 minus, it's a polyatomic ion, ionic compound. Potassium nitrite. Potassium nitrite. Nitrite, NO2 minus, polyatomic ion, then it's ionic compound. Magnesium sulfate. Sulfate, polyatomic ion, ionic compound. Ammonium chloride. Ammonium chloride, NH4 plus, ammonium, polyatomic ion, ionic compound. For that, you have to memorize the polyatomic ion. Now, without memorizing polyatomic ion, you can't do chemistry. You should memorize polyatomic ion. You can't ignore that. You can't jump out of that. Don't look at the challenges and just skip and go. Everything will add up and finally become a stress only. It won't give you any relief. It won't take a long time to memorize this. Maximum half an hour you can memorize. Believe me. If you don't believe yourself, I don't care. Believe me, within half an hour you can memorize and finish it. Maybe tonight you just do it. Don't keep it for tomorrow. After the session, sit another half an hour, memorize the polyatomic ion, and finish. No, chemistry is done. No, I think don't keep those things again and again. Still, some people don't know the periodic table. They are keeping it to be memorized later. No, memorize it now. Tonight, finish it. Whatever I'm writing here, if you feel you don't know that, you didn't memorize that, it's not there in your mind. Memorize it, study it, finish it today, and go to the bed. I think without that, don't sleep. No point. Without finishing the day fully, don't go to the bed. What's the point? You're not used your day fully. What's the use in living today then? When you're living, every second live to the maximum. Give your maximum. Every day when you're going to the bed, go with a full completed day. Don't keep with blank days. Don't keep blanks in your days and go to the bed. No point. Before going to the bed, finish the full day. Finish the work for that day. If you have a plan of finishing a lesson today, finish it and go to the bed. Don't waste the time now. Have targets on finishing things. Finish it. Without that, don't complete it. In the polyatomic ion, if you're still keeping it to be memorized later, this is the last chance. Today is the last chance. After the session, you take another half an hour, sit and memorize and go to the bed. Huh. So if you see any polyatomic ions, that is also ionic compound. Now, under the chemical bonds, big box is given. Big box is given. I want you all to quickly write the shortcut I give. And put a star at the bottom and write. If polyatomic of a grade 10s, we did this recently, ions involved, it's also ionic. Quickly work. Don't just look and write the same periodic table. Try to write by your own. Okay. Shall I change? Hurry, right. Now, for covalent structures, Lamai, for covalent compounds, we draw Lewis structures. For covalent compounds, we draw Lewis structures. In Lewis structures, we use single bond. Single bond is one line. We use double line. Double line is double bond. Triple bond is there. Triple bond is 3 lines. I'll teach a shortcut for you all to draw Lewis structures as well. A shortcut to draw Lewis structures. Remember this. Group number, number of bonds, number of free electrons. First look at you. Right. Group 7 elements forms one bond, will have 6 free electrons. First look at this very carefully. Group 7 elements make one bond, have 6 free electrons. Group 6 elements forms 2 bonds, will have 4 free electrons. Group 5, 3 bonds, 2 free electrons. Group 4, 4 bonds, 0 free electrons. Look at the pattern. Group 7, group 6, group 5, group 4. Number of bonds 1, 2, 3, 4. Number of free electrons 6, 4, 2, 0. Group 7. I'm starting with group 7 because group 8. Tell me group 8 elements. Helium, neon, argon. Do they make any bonds? Does helium, neon, argon make any bonds? No. So we don't start with group 8. Group 7, group 6, group 5, group 4. 1 bond, 2 bond, 3 bond, 4 bond. Free electron 6, 4, 2, 0. And sir, then group 3, group 2, group 1, they form ionic bonds mainly. You can't see them in covalent compounds. So you don't have this logic for them. Group 7 makes 1 bond, 6 free electron. Group 6 make 2 bonds, 4 free electron. Group 5 make 3 bond, 2 free electron. Group 4 make 4 bond, 0 free electron. Now for that, first of all, you should know what are the elements you have in that group. Group 7, what are the elements we have? Fluorine, chlorine. Group 6, what are the elements we have? Oxygen, sulfur. Group 5, nitrogen, phosphorus. Group 4, carbon, silicon. Now how this shortcut is used? How this shortcut is used? First we'll take homoatomic molecule. Hydrogen. Hydrogen also there's a shortcut. Hydrogen is not there in this shortcut. Hydrogen, the shortcut is this. Hydrogen, the shortcut is this. Hydrogen always makes single bond, no free electrons. Hydrogen always makes single bond, no free electrons. So again tell me the shortcut. Group 7, 1 bond, 6 free electrons. Group 6, 2 bond, 4 free electron. Group 5, 3 bond, 2 free electron. Group 4, 4 bond, 0 free electron. Hydrogen, 1 bond, no free electron. One more time. Group 7, 1 bond, 6 free electron. Group 6, 2 bond, 4 free electron. Group 5, 3 bond, 2 free electron. Group 4, 4 bond, 0 free electron. Hydrogen, 1 bond, no free electron. I will draw some structures. See, hydrogen, fluorine, chlorine, oxygen, nitrogen. These are homoatomic molecules. Same type of atoms are there. Homoatomic molecules. We'll try to draw their Lewis structures. On H2, H2 hydrogen na there. What's the logic I taught you? Hydrogen forms one bond, no free electron. Hydrogen forms one bond. Hydrogen forms one bond, no free electron. Hydrogen forms one bond. Hydrogen forms one bond, no free electrons. Fluorine, F2. Two fluorine atoms are there, F and F. Tell me, fluorine is in which group? Did these things to come into your mind? Fluorine is in which group? Fluorine is in which group? Seventh group. Seventh group, what is our logic? Seventh group forms one bond. Onna puta one bond. How many free electron? 6 free electron. 2, 4, 6. 2, 4, 6. That is fluorine. Chlorine, Cl2. 2 chlorine atoms are there. Again, tell me, chlorine is in which group? Chlorine is also in which group? Seventh group. Group numbers are given in Roman numerals. Chlorine also in seventh group. What's the logic? 1 bond, 6 free electron. 1 bond, 6 free electrons. 6 free electrons. Next, coming to O2. O2. 2 oxygen na there. O2. 2 oxygen na there. Onnalamai. This is 1 oxygen. This is another oxygen. 2 oxygen. Tell me, oxygen is in which group? Oxygen is in which group? Sixth group. Sixth group. What is our logic? What is our logic? Sixth group. 2 bonds. 2 bonds. 2 oxygen always tries to make 2 bonds. 2 bonds. How many free electron? 4 free electron. 1, 2, 3, 4. This side also 1, 2, 3, 4. N2. 2 nitrogen are there. N and N. Nitrogen is in which group? Fifth group. Fifth group, what is our logic? Fifth group, what is our logic? 3 bonds, 2 free electron. 3 bonds, 2 free electron. Nitrogen forms 3 bonds. 1, 2, 3. Always nitrogen tries to form 3 bonds. Keep that in mind. Always oxygen tries to form 2 bonds. Nitrogen 3 bonds, 2 free electron. 2 free electron. Those are the homoatomic molecules we have. Now we'll go to heteroatomic molecules. I'll use this shortcut separately, then I'll locate it there. Right. Heteroatomic molecules. Water, H2O. Different atoms are there. Heteroatomic molecules. Carbon dioxide, CO2. Heteroatomic molecule. Different atoms are there. Ammonia, NH3. Heteroatomic molecule. Methane, CH4. Heteroatomic molecule. We'll try to draw their structures. Water, H2O. 1 oxygen is there. 2 hydrogen are there. 1 oxygen, 2 hydrogen. 1 oxygen, then oxygen is called as the central atom. 1 oxygen is there. 1 oxygen is there. Therefore, oxygen is called central atom. At the center, oxygen. 2 hydrogen are there. 2 hydrogen are on either side. Now, water, the structure comes like this. It comes in V shape, bend shape. So you try to draw it in that shape, right? Water, 1 oxygen, 2 hydrogen either side. The logic I told you, hydrogen makes 1 bond, no free electron. See, this hydrogen makes 1 bond, no free electron. This hydrogen also makes 1 bond, no free electron. No free electron. Right. Hydrogen story over. Come to oxygen. Oxygen. Oxygen is in group 6. Group 6, how many bonds? 2 bonds. See whether there are 2 bonds. 1 bond here, One bond there. Two bonds are there. Oxygen makes two bonds. How many free electrons? Four free electrons are there for oxygen. One, two, three, four. That's the structure of water. Ammonia. One nitrogen, three hydrogen. One nitrogen, three hydrogen. One nitrogen. One nitrogen is the central atom. One nitrogen is the central atom. Three hydrogen are there. Three hydrogen are there. They are around the nitrogen. What's the logic I taught you? Hydrogen makes one bond, no free electron. Then this hydrogen makes one bond, no free electron. This hydrogen makes one bond, no free electron. This hydrogen makes one bond, no free electron. Now come to nitrogen. Nitrogen is group 5. Nitrogen forms how many bonds? 3 bonds. See whether there are 3 bonds. 1, 2, 3. Automatically number of bonds will be completed. 3 bonds. How many free electrons are there for nitrogen? 2 free electrons. See whether there are 2 electrons. 1, 2. Carbon dioxide. 1 carbon, 2 oxygen. 1 carbon, 2 oxygen. Carbon central, oxygen. 2 oxygen are there around it. What's the logic I taught you? Oxygen. Oxygen is group 6. Group 6 form how many bonds? 2 bonds. Oxygen forms 2 bonds. This side also you have oxygen. Oxygen forms 2 bonds. How many free electrons are there for oxygen? 2 bonds gone. 4 free electrons. 1, 2, 3, 4. 1, 2, 3, 4. Oxygen story over. Come to carbon. Carbon is in group 4. What's the logic? Group 4 forms 4 bonds. See whether there are 4 bonds. Automatically bonds will be completed. See whether there are 4 bonds. 1, 2, 3, 4. 4 bonds are there. Is there any free electron for carbon? No. That's the structure. Come to methane. Understand the logic here. Come to methane now. 1 carbon is there, carbon central. 4 hydrogen are there. 4 hydrogen are on all the 4 sides. What's the logic? Hydrogen makes 1 bond, single bond. This hydrogen 1 bond, this hydrogen 1 bond, this hydrogen 1 bond, this hydrogen 1 bond. No free electron for hydrogen. Carbon. Carbon makes 4 bonds. 0 free electron. Check whether there are 4 bonds. 1, 2, 3, 4. 0 free electron. Understood how to do Lewis structures? Nothing big. Just this short. Okay. Very simple. Using this, you can draw any Lewis structures. Not only this, any Lewis structure you can draw. Using the shortcut. What's the shortcut? What's the shortcut? Tell with me. What's the shortcut? Group number. Group 6. Sorry. Group 7. Group 7. 1 bond. 6 free electrons. Group 6. Group 6. 2 bonds. 4 free electrons. Group 5. 3 bonds. 2 free electrons. Group 4. 4 bonds. 0 free electrons. Hydrogen. 1 single bond. That's the logic. Now, most of the time in the exam, you won't get known symbols like this. You'll get unknown symbols. X is there, Y is there, Z is there. These are their group numbers. Draw their Lewis structure. Then if you know the logic, you can draw them. If you know the logic, you can draw them. Huh. Now, in the shortcut part, write the shortcut. Under that, in the big box, I want you all to draw all those structures. Done. Okay. Anybody needs more time? Yes. Okay. Take about 2 minutes. Okay. Right. Mm, 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 mm. Right. We'll finish the next part and do the question at once. Right. Uh, now coming to the initial thing. Quantification done. Bonding done. Now coming to the initial thing. Initial thing. First, ionization energy. First ionization energy. Listen. Name. What is this first ionization energy? Listen very carefully. What is first ionization energy? Let's say I have an atom. I have an atom. I want to remove an electron from this atom. I want to remove an electron from this atom. I want to remove an electron. Atoms have electron. I want to remove an electron. If I just go to the atom and ask, atom, can you give me one electron? Will it give? No. Atoms are like your siblings. You go to your sibling and ask, can I have that dress that you have? Can I take it for one day? Can I use your pencil? Can I use your pen? Will your sibling give? In the history of siblings, siblings will never give. Atoms are the same. If you go to the atom and just ask, can I get the electron from you? Can I take an electron? No, atoms won't give. If you want the atom to release that electron, if you want to take that electron, if you want to take it out from that atom, then what you should do, you should go and supply some energy. You give some energy, you fight with the atom, then you remove the electron. If you want to remove an electron from the atom, you can't just go and ask from the atom. You have to go, you have to fight with it, you have to supply some energy. Only if you supply energy, only if you give energy, you can remove an electron. Only if you give energy, you can remove an electron. There will be a minimum energy you need to give to remove an electron. There will be a minimum energy. There can be maximum, but there will be a minimum energy with which we can remove electron. There can be a minimum energy with which you can remove an electron. That minimum energy is called first ionization energy. Then simply, what is first ionization energy? Minimum energy supplied to an atom to remove an electron. Well, repeat with me, open the mouth and repeat with me. Don't just sit and watch this video as if you are watching a movie. You will feel sleepy. Repeat with me. What is first ionization energy? Minimum energy supplied to an atom to remove an electron. What is the minimum energy? What is the lowest energy you can give to an atom so that you can remove an electron? Minimum energy supplied to an atom to remove an electron. Now, if you take matter has three states. No? Solid state is there, particles are tightly packed. Liquid state is there, particles are slightly loosely packed. Gaseous state is there, particles are very loosely packed. You all tell me in which state you can easily remove electron. In tightly packed solid state, in somewhat loosely packed liquid state, or very loosely packed gaseous state. In which state it's easy to remove electron? Which state? Is it a tightly packed state or loose state? Loose state. What is that? Gaseous state. So you can remove an electron with the minimum energy, with the lowest energy, in what state? Solid state, the liquid state, the gaseous state? Gaseous state. In gaseous state only you can remove an electron with minimum energy. In solid state, you need to give high energy, lot of energy. It's not minimum. It's high, maximum. In liquid state, you need to give energy more than gaseous state. But gaseous state, you can give the minimum energy to remove an electron. So first ionization energy is defined for what state? Gaseous state. It's defined for gaseous state. Now we'll put that also into our definition. What is first ionization energy? Minimum energy supplied to an atom at gaseous state to remove an electron. Repeat with me. Minimum energy supplied to an atom at gaseous state to remove an electron. Now, if I remove an electron, will it still remain like atom? No. If I remove electron, it will turn into a positive gaseous ion. It will turn into unipositive gaseous ion. Unipositive gaseous ion can unipositive. Uni means 1. Positive plus 1. Unipositive plus 1 gaseous ion. Harine lamai. From sodium, if I remove an electron, it will become Na plus 1. Unipositive plus 1 gaseous. You are starting the state with gaseous sign. From sodium, if I remove 1 electron, it becomes unipositive, Na plus 1. From potassium, if I remove an electron, it becomes K plus 1. So it becomes unipositive gaseous sign. Now put that also into first ionization energy definition. What is first ionization energy? Minimum energy supplied to an atom at gaseous state to remove an electron and form unipositive gaseous ion. What is first ionization energy? Minimum energy supplied to an atom at gaseous state to remove an electron and form unipositive gaseous ion. Repeat with me, open the mouth and repeat with me. What is first ionization energy? Minimum energy supplied to an atom at gaseous state to remove an electron and form unipositive gaseous ion. Should you memorize these energy values? Sodium will have a certain energy value. Potassium will have a certain energy value. Magnesium will have a certain energy value. Should you memorize it? No. But if you look at the energy variation across the periodic table, it shows us a pattern. If you look at this energy variation, first ionization energy variation across the periodic table, it gives us a pattern. It shows us a pattern. That pattern you should know. You don't need to know the numerical values. You should know the pattern. How to memorize the pattern? Very simple. Memorize this rhyme. Memorize this rhyme for the pattern. What's the rhyme? Down. You start with down. Down, up. Down, up, up. Down, up, up. Where? Tell with me. What's the rhyme? Down, up, up. Down, up. On the last sentence, tell me. Down, up, up. Down, up. One more time. Down, up, up. Down, up. Now the family people will be wondering, what is this sir doing at midnight teaching rhymes? One more time, memorize the rhyme. Down, up, up. Down, up. One more time. Down, up, up. Down, up. Alright, this is coming in first ionization energy. Lamai, see, this is the first ionization energy variation across a period. Period kiyanne, what is period? What is period? Horizontal rows. Horizontal rows in the periodic table is period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. That is your second period. The first period, hydrogen and helium. Third period, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Fourth period, potassium, calcium. These are periods. First ionization energy variation across a period is that rhyme. Down, up, up. Down, up. These are confusing. How that rhyme becomes the pattern on. Now see, will you? I'll draw the graph and show you. Y-axis. X-axis. Y-axis is going to be first ionization energy measured in kilojoules per mole. Remember that. First ionization energy is measured in kilojoules per mole. X-axis is your atomic number of the elements. Now, what's the first ionization energy variation across a period? Down, up, up, down, up. I'll take a period. Now, first period, nothing to take. Hydrogen, helium is only there. No? We'll keep it. Finally, I will teach about that. Keep hydrogen, helium. Take the second one. Second one is a nice period. It has a nice order, right? What's the first ionization energy variation across second period? Down, up, down, up, up, down, up, up. A kiyanne. You start from down. You start from down. Down, up, go up. Down, little down. Not below the previous down, eh? Not below the previous down. See? Down, up, down, up, up. Two ups. Now down. This down is not below the previous one. Not below the previous one. Down, down, up, down, up, up, down, up, up. See whether it connects with the rhyme. Down, you start from down. Down, up, down, up, up, down, up, up. Arine? Down, up. Now down, down, up, up, down, up, up. This is the first ionization energy variation across second period. How? Take the second period. What are the elements we have in the second period? What are the elements we have in the second period? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. That's your first ionization energy variation across second period. Okay. Neon. Okay, and just tell me, in the second period, who has the highest first ionization energy? In the second period, who has the highest first ionization energy? Neon. Who has the lowest? Lithium. This for second period. Then, sir, third period. Third period, what is there? Or sodium, magnesium, that section. Third period. Again, the same order. But you're starting like this. The start is like this. Third period, you start slightly below the second period. Second period, see, you know? Third period, you start slightly below. This is second period. Third period, slightly below. You start from here on, down. You start it somewhere there. Down, up. You start it slightly below. Down, up. Down, up, up. Down, up, up. See, down, up, down, up, up, down, up, up. Now we'll fill the elements. Third period. This is the third period. What are the elements in third period? What are the elements in third period? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Now connect them. Second and the third, you connect. In the third period, who has the highest? Argon. Who has the lowest? Sodium. Now go to the fourth period. Fourth period, only calcium, potassium and calcium are there. Again, you start it in the same order. Again, you start in the same order. You start slightly below this. You start slightly below this, somewhere here, down, up. Only two elements are there. Fourth period, only two elements are there. What are the two elements? Potassium, calcium. Potassium, calcium. Now you join them. That's your fourth period. Now what is remaining? First period. Hydrogen and helium. Only hydrogen and helium are remaining. Now see, can you see? Period by period, graph is going down. Lithium started here. Sodium down. Potassium down. Period by period, graph is going down. So what you can tell about hydrogen? Above lithium or below lithium? Now come in front. Above lithium or below lithium? Above. Hydrogen should be above. Hydrogen should be above lithium. Hurry, hydrogen. What about helium, 8th group? If you start above, you finish also above. Lithium here, neon there. Sodium started below that. Argon is finishing below neon. So here you're starting above, you finish also above. So helium will be the highest. Helium will be the highest. Helium will go to the top. Understand the logic here? You start here, 8th group highest. You start here, 8th group. You start below, 8th group. So looking at the overall graph, tell me which element has the highest first ionization energy? Which element has the highest first ionization energy? Helium. Which element has the lowest first ionization energy? Lowest? Potassium. Usually 8th group are highest, first group are lowest. 8th group highest, first group lowest. HRI first ionization energy. First ionization energy is minimum energy that should be supplied to an atom in gaseous state to remove an electron and form unipositive gaseous ion. Pattern down, up, down, up, down, up. See, down, up, down, up, down, up. Here also down, up, down, up, down, up. Here the down is slightly slanted that way. Eva don't need to worry. You can draw it in the normal way. So if you look at the graph, helium the highest, potassium lowest. 8th group elements are highest, first group elements are lowest. Highest is helium, 8th group element, lowest is potassium, first group element. That is first ionization. Understood first ionization? Understood first ionization? Yes. Last part. Last part. What's the time? 11:54. Last part. We'll tell good morning today and finish. We'll finish the day with good morning, not good night. Huh? Electronegativity. Electronegativity. What is this electronegativity? What is electronegativity? Ability of an atom to attract the bonded electrons towards itself. Electronegativity. Ability of an atom to attract the bonded electron towards itself. Let's take HCl. HCl molecule. Hydrogen and chlorine are bonded. Electronegativity of hydrogen is low. Electronegativity of chlorine is high. Electronegativity of chlorine is high. Chlorine has a high electronegativity. Then what will chlorine do? Chlorine will attract the bonded electrons towards itself. Lamai, in the bond we have electrons. In the bond we have electrons. Those electrons will be attracted towards chlorine. Why? Chlorine's electronegativity high. So what is electronegativity? Ability of an atom to attract the bonded electron towards itself. So chlorine will pull the electron towards itself. That is electronegativity. Ability of an atom to attract the bonded electron towards itself. How do we measure the electronegativities? How do we measure electronegativity? Using a scale called bowling scale. Using a scale called bowling scale. Sorry. Using a scale called bowling scale. Should you memorize the bowling scale? No need. But can you memorize it? Yes. It's not hard. It's easy. We'll memorize it. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium. What are their electronegativity values? Hydrogen you memorize separately, 2.1. Now it's a memorize. Hydrogen 2.1, hydrogen 2.1, lithium 1.0, beryllium 1.5, boron 2.0, carbon 2.5, nitrogen 3.0, oxygen 3.5, fluorine 4.0. Can you see a pattern? 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0. Can you see the value is increasing in a uniform manner? Sodium. This is 1.0, no? Reduce 0.1. 1.0 minus 0.1, 0.9. Increase by 0.3 until phosphorus. Increase by 0.3. 0.9, 1.2, 1.5, 1.8, 2.1. Now you increase by 0.4, 2.1, 2.5. Now you increase by 0.5, 3.0. See? 0.9, increase 0.3. Just ignore the decimal. Ignore the decimal. Increase by 3, 9, 12, 15, 18, 21. Now add 4, 25. Add 5, 30. So basically here also you have increment. Potassium 0.8. Look at the order here. 1.0, 0.9, 0.8. There also you have a pattern. This is 0.8. This is 1.0. Hydrogen 2.1. Lithium 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0. Sodium 0.9. Increase by 0.3. 1.2, 1.5, 1.8, 2.1. Stop. 2.5, 3.0. Now 0.8, 1.0. Not hard, ne? Here you add 0.5. Here you add 0.3 until phosphorus. 0.4, 0.5. These two, if you want, you memorize separately, memorize this separately, memorize. Happy. I will write the 8th group, no. Helium neon nag. Helium neon nag. Why didn't I write that? I forgot it neither. You all also didn't tell, no. You all were keeping quiet. Ramai, first tell me. 8 group element, will they make any bonds? Helium neon argon, do they make any bonds? No. How many zeros? No. If they don't make any bond, can they attract bonded electrons? Again, no. If so, will they have any electronegativity values? Again, no. Then should I write it here? Should I write it there? No. No need. They don't have electronegativity values. They do not make any bonds. They do not attract any bonded electrons. So they don't have any values. If I draw a graph, polling scale, I'll just write it in short. Atomic number, atomic number, atomic number. Keep hydrogen will start from the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen. What can you tell? Increasing, neither. Linearly increasing. 1.0, 1.5, 2.0, 2. Nicely, linearly increasing. There's a linear increment for the second period. Hydrogen, sorry, second period. No? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Come to third period. You're starting slightly below lithium, neither. You're starting slightly below lithium. Here also you have an increment. Here there is a higher slope, higher gradient increment, but overall there is an increment. Towards the end, there is a higher slope. The third period also, you start below lithium. You start below lithium, but there is an increment. There is an increment. Oh, there is an increment. That is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Finally, potassium, calcium. You start below sodium. You start below sodium, again increment. You start below sodium, again increment. Potassium, calcium. Hydrogen, 2.1. Somewhere in the middle. Somewhere in the middle. Somewhere in the middle. Somewhere here, you have hydrogen. Join. Tell me who has the highest first electronegativity? Which element? Highest is fluorine. Lowest is potassium. Is there 8 group elements here? Is there 8 group elements? No. No 8 group elements. Remember, 8 group elements are only there in first ionization energy. In electronegativity, no 8 group elements. Only in first ionization energy, you have 8 group elements. Here, no. HRI theories. Electronegativity. Ability of an atom to attract the bonded electron towards itself. Polling scale is used. 8 group elements, no electronegativity value. Pattern, linear. Values are given. Chart is given. Highest, fluorine, 7 group element. Lowest, potassium, first group elements. Dingala, shall we do the question? Work with me. Yeah, by the way, good morning all. 2nd August, month of August also started. Do the question with me. 2016, I remade the question slightly because grade 10s are there. There are about 2 questions there. They ask us to write the reaction, which all of you can't do. Grade 10 students can't do. But grade 11s, of course, if you can find the 2016 knowledge, but try to do the correct one. There's a question where they ask the reaction. Try to write the reaction as well. Hurry. A. AEGJLMQR. Are 8 consecutive elements in the periodic table. Consecutive means in order. The atomic numbers of all these elements are less than 20. Okay. E naturally occurs in allotropic forms. Allotropic forms. Lamai, only two elements are there in our syllabus with allotropic forms. Only 2 elements are there with allotropic forms. One is sulfur, the other is carbon. Only these two has allotropes. Only these two has allotropes. E naturally occurs in allotropic forms, and one form conduct electricity. Onnalamai, that is your confirmation sentence. One form conduct electricity. Tell me, out of sulfur and carbon, which one can conduct electricity? Carbon. Carbon graphite can conduct electricity. So here they are talking about what? Carbon. Remember, carbon graphite can conduct electricity. They are talking about graphite here. Carbon graphite can conduct electricity. The moment you hear allotropic form conduct electricity, they are talking about carbon. Allotropic form conduct electricity, guarantee they are talking about carbon. So E is what? E is carbon. E is carbon. Now we'll find out all the other elements. Before doing the question, find out the elements. So it will be easy for you. It will be easy for you. These are consecutive elements, no? Now we know. Now we know what we know. This is carbon. These are consecutive elements. What is there before carbon? What is there before carbon? Boron. So A is boron. After carbon? Nitrogen, oxygen, fluorine, neon, sodium, magnesium. Agree? Hard. What's the first question asking? What is the element E? Carbon, carbon, take 1 marks, carbon. Roman 2. Of the above element, which element occurs as noble gas at room temperature? What's the answer? Noble gas at room temperature. Noble gas at room temperature is neon here. No, neon කියලා ලියන්න නැහැ ළමයි. Neon නේ එළදරදිල්ල. What is neon? M. You write M. B. Which element has the highest electronegativity? Highest electronegativity is which group? Tell me. Which group? First tell me the group. Which group highest electronegativity? Seventh group. Tell me which one is there in the seventh group here? Fluorine කියන්න fluorine කියන්න fluorine சொல்றதில்ல. What is the element given here? Fluorine is what? L. Fluorine is L. Your answer is L. Grade 11, take the paper. There is another question there, C question. Do that C question as well. I told you I remade this question. C question, grade 11s can do. You all do. Roman 3. Draw the Lewis dot diagram. Adiyappa dot diagram they are asking. Of a molecule formed by the element G with hydrogen. What is G? What is G? G is nitrogen. G is nitrogen. Nitrogen and hydrogen. Nitrogen and hydrogen. On Lamai, tell me nitrogen and hydrogen. What should be the element? What should be the element? Nitrogen and hydrogen. Ammonia, NH3. You can't write for NH3. What they are talking? G. Nitrogen is G. You can't write for this. Nitrogen is G. GH3. Now, this is your ammonia, not NH3. You can't write NH3. Nitrogen is not there in that context given. Nitrogen is G. GH3. Can you all remember the Lewis structure? The shortcut I told you. What's the basic Lewis structure? Nitrogen is there. 3 hydrogen are there. The nitrogen is fifth group. Fifth group forms 3 bonds. Fifth group forms 3 bonds. Can remember that. Fifth group. This is where the shortcut helps. Fifth group forms 3 bonds, 2 free electrons. Hydrogen always form 1 bond, no? 1 bond, 1 bond, 1 bond. Hydrogen no free electrons, no? Nitrogen forms 3 bonds. How many free electrons? 2 free electrons. If you draw this, you're wrong. They're not talking about nitrogen. They're talking about G. So instead of nitrogen, what you should put there? G. Still, will you get marks? No. Why? What are they asking? Lewis dot diagram. Convert it into Lewis dot diagram. Don't go to study dot diagram. I didn't teach all. Study Lewis structure. Convert to dot. Convert to dot. How to convert? How to convert? 1 bond means how many electrons are there? 1 bond, how many electrons are there? 2 electrons are there. 1 bond, 2 electrons are there. So this bond, how many electrons are there? 2 electrons. 2 dots. This bond, how many electrons are there? 2 electrons are there. Again 2 dots. This bond, how many electrons are there? 2 electrons are there. Again 2 dots. However, 2 free electrons are there. 2 dots. Onna puta. That is the Lewis dot diagram. That's your Lewis dot diagram. For that, you'll get marks. Don't draw hydrogen this much far. හරිද? හරිද? Last question. See how things are easy, eh? For this chemistry only, you all were crying. Copy the diagram below into your answer script and draw a sketch of the variation of first ionization energy of the above elements. This is a O-level paper, eh? 2016. It is not necessary to show the atomic number and values of the ionization energy. It is sufficient to mention only the elements. Hurry. What are the elements we have? A, E, G, O, L, M, Q, R, neither. I'll draw it separately. A, E, G, O, M, N, Q, R. Boron, carbon, nitrogen. එහෙම දෙයක් නේ. A, E, G, O ද? A, E, G, J. G, J. G, J is there. Not G, O. It's J. It's J, lamai J, not O. A, E, G, J, M, N. Carbon, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. හරිද ළමයි? Okay, අඬකු. හරිද? E, G, J, L, M. What is missing? අම්බේ දැන් නම් lazy. Now lazy. Brain is not braining. What is missing? A is there, E is there, G is there, J is there. L is missing නේ. එකනේ ළමයි. L is missing. Where did L go? J, L, M, Q, R. හරි. Oxygen. හරිද? J, L, M, Q, R. හරි. Nitrogen, oxygen, fluorine, neon, sodium, magnesium. We'll draw the first ionization energy variation. First divide it into periods. These two are third period. This set is second period. First ionization energy graph. First ionization energy, atomic number. What's the pattern? Down, up, down, up, up, down, up, up. I'll first finish the second period. Eh? Pana don't start from boron here. Boron නෙවෙයිනේ. This should be lithium. Lithium, beryllium, නැතුව you start. Which means I'll come in reverse. I'll go reverse. I'll go from neon. What is neon? Neon is M. This is M. Fluorine, L. Oxygen, J. Be careful. Nitrogen, G. Carbon, E. Boron, A. Which means other two are not necessary. These two are not necessary. Agree with the second period pattern? I erase the first two. Yes. Now come to the other one. Sodium, magnesium. Drop, drop down, down, up. What are the two? Sodium, magnesium. Don't write sodium, magnesium. What should come there? Q, R. Those who got this pattern? Those who got this pattern? Got it. A, E, G, J, L, M, Q, R. Got nailed. That is that. Ta-da! Chemistry backup is done. I didn't go towards the YouTube. Mm, okay, yeah. Hari nail. Hey, this is not chem night tank. Night session I do until early morning. This is not chem night. Just a chem backup. We can tell chem midnight. Finish at midnight. Not chem night. A YouTube live I will keep it. If you want to revise, you can go through it. The, the, whatever we did today, you can revise it. I think grade 11 group 2 is also full. I opened another group, third group. I'll publish the link. So if there are YouTube people, if anyone YouTube after this, if you're watching, you want to join the group, if the first group and the second group are full, join the third group. Tute PDF also, I'll keep it as a description in the YouTube. So you can watch it any time you want. Plus, from my end, yes, what I planned is done. From your end, if your plan is not yet over, which means I told you, if polyatomic ions are yet to be memorized, memorize and finish it. If you have something remaining to be memorized from whatever the sections we did today itself, memorize, put it to the mind and finish it. Don't go to the bed without finishing what you planned for today. So whatever we did, finish it and go to the bed today, right? Finish it and go to the bed today. So those are the things I want to tell. Keep studying hard now, especially the grade 11s. Time is getting closer. I don't tell you have a lot of time. You have very limited amount of time. Allocate the time for what is more important, what is more prioritized. Work accordingly. Give your maximum. Work with your fuller spirit during this next 6 months. Because next 6 months are going to be your life changing 6 months. Whatever you did for the last 11 years doesn't count. You became class first always, you became class last always, doesn't matter, doesn't count. What you do for the next 6 months will drift your full life. Hinda, focus here. You are doing this for a purpose. Don't tell you are doing this for your mother, you are doing this for your father, you are doing this for your teachers. You are doing this for you. Ask from yourself and see. If you are doing something for you, if not, you will leave this. You will give it up. Nah, you are doing this for you. You are writing this exam for you. So if you are doing something for you, don't do it in normal way. Don't do it in the general low quality way. Do it in the best way and finish it. You will have a best high potential. So go to that high potential, maximum potential and finish it because you are doing something for you. Don't put yourself down. You are the best maximum you yourself can give. Aim the give your maximum for this and finish it. Or keep working. I'll be again and again meeting hereafter again. Some more plans are there. Right? 6 months now for level batch especially. 6 months now. Some more new plans are there. I'll update in the WhatsApp group. Stay in the WhatsApp group. So keep working. I'll meet you all again.